Hello everyone. In this video we will understand about C operators. An operator is basically a symbol which specifies the operation that has to be performed, like mathematical, logical, relational. Okay, so an expression is any combination of an operand and an operator that yields a value. Okay, so an expression is made up of an operand and an operator, and this operator, it decides what operation you are taking on this operand. C provides us with various types of operators which can be classified into arithmetic operator, equality operator, relational operator, logical, bitwise, and assignment. The arithmetic operators can further be classified into unary, binary, and ternary based upon the number of operands. For example, if an operator takes only one operand, like unary minus, increment operator, decrement operator, these operators they operate on a single operand. Such operators are called as unary operators. Now, if at all an operator takes two operands, like a plus b, a minus b, such operators are called as binary operators, which takes two operands. Ternary operators, they take in three operands. For example, this operator, we also call it as a conditional operator, like a, where a, b, and c, they can be expressions. Okay, so basically this operator, it takes in three operands, and hence the name ternary operator. Okay, assignment operators, they are further classified into simple assignment, compound assignment, and an expression. In case of simple assignment, we have equal to. Compound assignment, we have the other operators, we shall discuss it, and an expression. Right, we'll have a detailed understanding of the arithmetic and assignment operators. As discussed, unary operators, binary operators, and ternary operator is a classification for your arithmetic operator. So unary operators are unary plus, unary minus, increment and decrement operators. Binary operators like addition, subtraction, multiplication, division, and modulo. These are called as binary because they operate on two operands. Okay, ternary operator, as discussed, they operate on three operands, hence the name ternary. Coming to assignment operators, we have simple assignment, compound assignment, and an expression. Simple assignment is an equal to operator, okay, which assigns a right hand side value to your left hand side. That is, the value of b is stored into your a, or you can have something like this: a is equal to 5, wherein 5 is stored in a. Compound assignment, if at all I have an expression like this, if I have an expression like a is equal to a plus 5, that is, in my RHS, if the left hand side operand is getting repeated, I can have a compound assignment as a plus is equal to 5. Similarly, I have something like this: b is equal to b minus 10. Again, in my right hand side, if the left hand side operand is getting repeated, I can write it compactly as b minus is equal to 10. The same thing holds good for multiplication, division, and modulus equal to. Okay, expression. Within an expression, we can have an assignment as this: a is equal to 5 plus b is equal to 8 plus c is equal to 2 minus 4. Here, as per the BODMAS rule, we start with the we start evaluating with the parenthesis, perform the assignment, evaluate the expression, and finally the result of the right hand side is assigned to your left hand side variable. Okay. Coming to the relational, logical, equality, bitwise and other operators, we'll just have a discussion on what are the various operators available. We have relational operators. The operators under this category are greater than, less than, greater than equal to and less than equal to. You have to remember one thing here, the relational operator will always give you the result as true or false. It gives you the result as true or false, and in C language true is expressed as 1 and false as 0. Now for example, if I have A is equal to 5 and B is equal to 10, and if I have something like A less than B, okay, this particular expression will give me the answer as 1 because the result is true. The result is true. So relational operator, you will not get the numeric value, you will get it as true or false. You will get the answer as true or false. Alright. Equality operators, these are used to check whether a left hand side is equal to or not equal to your right hand side. Again, we will take the same example. A is equal to 5 and B is equal to 10. Okay, now I want to check whether A is equal to B or not equal to B. If I have the expression like A is equal to B, single equal to is assignment, double equal to is used to check the equality. Okay, now this particular expression, again it will give me either true or false. In this case, the result of this expression will be 0. If I have something like this, A is not equal to B, this will give me the answer as 1. Okay, so relational operator will give me the answer or the result in terms of true or false. Same thing holds good for your equality operator also, true or false. Okay, coming to your logical operator, the same thing. The logical operator will also give you the answer in terms of true or false, that is 0 or 1. Now what are the various categories of operators? We have logical and, logical or and logical not. Okay, now here you have to remember one thing. If at all I have something like this, A is equal to 5, okay, B is equal to 6. If a value of a number is apart from 0, is not than 0, let it be a negative or a positive, okay, this is considered to be true. This is considered to be true. Okay, if at all I have something like this, M is equal to 0, only then this is considered to be false. Okay, now if at all I perform A and B, this will be evaluated as true and true, the result of which will be true. True ANDed with true is always true. Okay, I can even have something like this, minus 5 and 6. In this case also, if it is not 0, the particular number is considered to be true. Okay, here also it is true and true. Only if I evaluate it as A and M, where M is equal to 0, this will give me the answer as false. Okay, same thing holds good for OR and as well as NOT operator. We'll have a detailed discussion in a later part. Okay, bitwise operator. So these operators will give me value. As your arithmetic operator, these will give us the value. You have to just remember the difference between bitwise and logical AND. In case of logical AND, we use two AND operators or two ampersand. Here we make use of single AND. This is called as bitwise AND. Okay, these operators, they operate on bits. They operate on bits, that is 0 and 1s. Okay, so bitwise OR, complement, exclusive OR, right shift and left shift. Right. The other operators, like we have a comma operator, okay, in order to separate the various tokens and various operators or operations. Indirection operator, membership operators, okay, these are with respect to our pointers, okay, and size of operator is used to check the size of a data type. It is used to check the size of a data types. Okay. Now few things to note when we are dealing with arithmetic operators. In case of binary operators, in case of binary operators, that is your plus, minus, multiplication, division and modulus, all operators, all these operators except the modulus operator, they can take a mix of integer and floating point values as their operand, but for modulus operator the operands must be integer. The operand must be an integer. We all know modulus is used to give you the remainder, this is used to compute the remainder, okay, and this is used to give the quotient. This is used to give the quotient. For example, I have a is equal to 10 and b is equal to 8. When I perform a divided by b, okay, the answer will be 1. This is our quotient, okay. When I perform a mod b, this will give me 2. This is the remainder, okay. You should know the difference between division and modulus, right. Now, if both the operands are real, in case of division operator, if both the operands are real, obviously the result will be real, okay. Now, if both the operands are integers, even though the result might come in terms of real one, but however you will not get the appropriate answer. In that case, what we do is we do something called as typecasting, okay. This is called as typecasting, okay. This is usually done to get appropriate answer. For example, I had cost is equal to 10 and volume is equal to 8, okay. This is not a perfect integer division. I mean to tell, we get the result in terms of fractions. Now, if at all I perform this without typecasting, I will get the answer as 1. To get the appropriate answer, I need to typecast this to a floating point value, right. So, when I typecast this volume to a float, okay, so it will be real by real division, I get the answer appropriately as 1.25, okay. As discussed, remainder modulus always expect the integer for both of its operand. Now, one thing you have to remember, there are chances that your arithmetic result that you get, okay, it does not fit into a variable because of its lesser size, okay. In that case, a condition called as overflow takes place and we do not get an appropriate answer. For example, I have something like this, okay. I have short int is equal to 1000 into some 544. I have this operation being performed. Since the answer does not fit into a range of short int, there will be an overflow and would not get an appropriate answer that is stored into A, okay. So, we should be pretty careful when initializing a data type for a variable, right, okay. We'll just have, yeah. Coming to your unary operator, yeah, as discussed, we have minus, which negates the value of the operand, okay. For example, I have a is equal to 5. Now, I want to negate this value, okay. So, I will have something like this minus a, okay. So, a numeric constant is assumed to be positive until it is preceded by a negative operator. Apart from this unary minus, we have two more operators, that is increment and decrement operator. There are two variants again depending upon where you place this increment operator. If at all you place this increment operator before an operand, this is called as pre-increment. If at all you place the operator after an operand, we call this as post-increment. Depending upon where you place this operator, okay, the result varies. The result of the expression varies. We will discuss it slowly. Similarly, decrement operator, the two variants are pre and post, which depends upon where you place the operator. So, this should be where minus minus, Okay, so here there is a small discussion. So you have I equal to 42. When I have I plus plus, increments the contents of A, which is same as I equal to I plus 1. Now the content of I will be 43. Okay, continuing further, I minus minus decrements the value of I becomes 42. Okay, again incrementing it becomes 43 and it becomes 42 when you decrement it, right? Now there are certain basic rules that has to be followed when using your increment and decrement operator. The first rule is that the operand must be a variable. It must be a variable. For example, I can have something like this, plus plus a, where a is equal to 5. Okay, it cannot be a constant or an expression. You cannot have something like this, plus plus b plus c. This is wrong. You will get a compile time error. Okay, you cannot have an expression, neither you can have plus plus 2. This is also wrong. You will get a compile time error. Okay, the other thing is that the operator may precede or succeed an operand based upon what result you want. Okay, yeah. Now the question comes in, what is the advantage of using these increment operators? Okay, it's basically whenever we have these increment operators incorporated in our expression, these expression will take a single machine instruction to get executed. Okay, single machine instruction to get executed. However, if at all I write it as a is equal to a plus 1, these take more than one machine instruction. Okay, one thing you have to remember, whenever I have a plus plus or a minus minus, whatever, it's always incrementing 1 or decrementing 1. It is not that you are incrementing or decrementing more than 1. Okay, it's always a plus 1 or a minus 1. Okay, so the advantage is that these expressions will be executed in a single machine instruction, something like optimizing. Okay, if at all I have a equal to a plus 1, it requires more than one machine instruction. We'll just have a look at programming examples. Okay, here value of a is equal to 5, value of b is equal to 3. Now I just want to print the result of this. Okay, now as discussed the rules, what should be the operand for increment operator? It should be a variable. You cannot have an expression. So as observed, you will get a compile time error. Okay, similarly when I execute this, I will get a compile time error. Okay, so care should be taken whenever we make use of increment and decrementing operators. Okay, now we'll have a discussion on what will be the result when we place the operator after an operand. Okay, and when we place this operator before an operand. Okay, what will be the difference? Now here let a is equal to 5. Okay, now in this case, okay, we have x as a variable and a as one more variable. Okay, value of a is 5. Now what does this expression mean? It basically means assign the value of a to x, in the memory increment the value of a by 1. Okay, so the first action is to store the value of a into x, and second is increment the value of a by 1. Right, so what does this happen? The first step becomes 5. You are assigning, in the memory you have to update the value of a by 1, that is 6. Right. Okay, similarly decrement operator, let us take b is equal to 10. Right, so what happens in this case? Y is a variable, b is one more variable, value of b is 10. So what does this expression mean? Assign the value of b to y, that is the first step. So I assigned it. The second step is decrement the value of b by 1. So this will become 9. right? This is your postfix expression. Why is it called as postfix? Because after assignment you will be evaluating the value of a. You will be incrementing or you will be decrementing. Prefix expressions, what are you doing here basically? Let us take a is equal to 5 again and b is equal to 10. Here it is reverse. I have x, I have a. Initially value of a is 5. Here if at all the operator you are placing it before an operand, okay, you have to first increment the value of a and then assign it to x, hence the name prefix. Okay, so in this case the first step is increment the value of a by 1 and then assign the value, that value, to your x, right? Same thing with pre-decrement also. So what happens here? Y is one variable, b is another variable, value of b is 10. So this is the first step, decrement the value and then assign it to y, right? Okay, we'll just have a look at one example here. Okay, the value of x is 4, right? Now I want to perform a post increment operator. So what happens in this case? Here we have x, value of x is 4. Okay, I have an expression as x plus 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 x. Now what does this mean? First use the value of x 4, increment the value by 1, 5 plus 5. Okay, so the result will be 9. Okay, so we'll just run this program. Okay, so the result is 9. Yeah. Now assignment operator, as we saw, there can be a simple assignment, there can be a compound assignment, or there can be an expression. So we just discussed it. N is equal to n plus 5, right? I can write it compactly as n minus equal to 5. If I write it as n into 5, this expands to, you have to repeat the left hand side operator once again, 5. Okay, so this evaluates to n is equal to n divided by 5. What does this evaluates to? N is equal to n mod 5. Coming to relational operator, right? So here the condition is that the operand, they must evaluate to a number, because we are checking the relationship between the two numbers using a relational operator. Fine. For example, a is equal to 5, b is equal to 10. Okay, these both are numbers. Now I can apply the relation operator here. Okay, points to consider: characters are valid operands for a relational operator because we have something called as ASCII values associated with every characters, right? But you have to keep one thing in mind: you cannot apply the relational operators to compare strings, because it is basically the address, right? Whenever we have something like this, hello is compared with hi, okay, relational operator and a hi, basically the addresses gets compared and we may land up in getting a wrong answer. So avoid using these operands for a relational operator. Use either numbers or you can make use of characters. You can make use of characters as the operand. Now, what are the various relational operators available to us? Its equality is also considered to be a relational operator. We have greater than equal to, greater than, less than equal to, and less than. Okay, as discussed before, relational operator will give us the answer in terms of true or false. It will give us in terms of true or false, that is 0 or 1, sorry, 1 or 0, 1 or 0, right? Now we'll just have a look at the example. Here a is 5, and b is 10. Okay, and I have assigned characters to m and n. When I run it, you can just observe the answers for various expressions here. Okay, so value of A is 5 and B is 10, A less than B, the result is true, so I am getting it as 1, right. Next is A is greater than B, right, the result is false, so I am getting it as 0. Okay, A less than or equal to B, answer is 1, A greater than or equal to B, answer is 0, A not equal to B, answer is 1, A equal to B, okay, the answer is 0, that is false. Now I am comparing the characters, M is less than N, okay, ASCII value of A is less than B, so it is 1, M is greater than N, the ASCII value of M is less than B, so it is false, right. So in this way we can have comparison, and remember your A and B can be expressions also, right. Coming to your logical operators, as discussed previously, these operators, they also give you the result in terms of 1 and 0, that is true and false. Okay, just remember this truth table for logical operator. We have A, okay, yeah, I'll just put it here, B, A and B, A or B, not of A, okay, 1 1, okay. So whenever both are false, your AND will be false, 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 true. So AND operator will give you true only when both the operands are true. In all other cases, the result will be false. 0, 0, 0, this is 1. Similarly, A or B, okay, this is false only when both the operands are false. In all other cases, it is true. In all other cases, it is true. So you have to remember this truth table for logical operators. Not of A, that is negating the values. So this becomes true, or 1, this becomes true, negation of A 0, or this is false and this is false. Okay, so what you have to remember in case of and OR, and is true only when both operands are true, okay, and OR, this is false only when both are false, okay. We'll just have a look at examples. So negation, if at all I have like this, 5 is equal to 5, condition is true, right. Negation of true is false, that is 0. Same thing, 5 is less than 6 for AND, 5 is less than 6, true, and 6 is less than false, true ANDed with false, the result is false, that is 0. 5 less than 6, true, 6 less than 5, false, true ORed with false is true, that is 1. Some more examples for negation. See, as discussed previously, any non-zero value is considered to be true, not of true is 0 or false, okay. 10 and 5, this is nothing but true ANDed with true, so answer is true. Again, true ORed with true, the answer is true, okay. We'll look with some programming examples. Here A is equal to 0, B is equal to 1 and C is equal to 2. A ANDed with B, right. So what should I get here? It is false. I'll just run it because we are ANDing 0 with 1, okay. Just have a look at the answer here. Yeah, A ANDed with B is 0, A ORed with B is 1 and negation of A is 1, right. Okay, coming to your bitwise operators, okay, these operators, they operate on bits. For example, negation operator, okay, this basically complements the value of x. In this case, I've considered the octal numbers, Okay, I've considered the octal numbers. So the decimal equivalent of this will be 9 and decimal equivalent of this will be 23. Right, now when I represent 9 in terms of binary, it'll be something like this: 0 0. Okay, now when I represent 23 in terms of binary, it will be 0 1 0 1 1 1. Right, so this is 9 and this is 23. When I perform negation of x, it is nothing but complementing the bits 0 1 1 0. Right, now if you compute the octal value for this, it will be nothing but 0 6 6. In decimal, this value is 54. Okay, now when I perform x ANDed with y, okay, how do I do it? It's a logical AND. I mean, it's when I perform an AND operation, it is 1 and 1 is 1, 1 and 0 is 0, 1 and 0 is 0, 1 and 0 is 0, 1 and 1 is 0 and 1 is 0, this is 0. So what is the answer I'm going to get? I'm going to get it as 1. The value is 1. Okay, when I perform an OR operation, just do the OR operation for the same. I'll just draw the line here. This is AND. When I perform an OR operation, so it will be 1 with 1 is 1, 1, 1, 1, 1 and 0. So this is our OR, right? So this will evaluate to octal 37. Okay, octal 37. Octal value of 37 and decimal will be 31. Okay, now what do you mean by an XOR operation? XOR has a truth table like this: A, B, A XOR B. So if at all I have 0 0, 0 1, 1 0 and 1 1, right? When both are same, the result is 0. When one of them is different, the answer is 1. Okay, so this is false, this is true, right? This is true and this will be false, right? So when I apply the same thing to our x and y, so x is 0 0 1 0 0 1 and y is 0 1 0 1 1 1. When I perform an XOR operation, okay, so this will be 0, this will be 1 1, this will be 1, this will be 1 and 0, right? So this is nothing but, in binary it is 30, in octal the value will be 36, right? Now coming to your left shift, we have this as x. Left shift is nothing but shifting the bits towards the left, So when I shift the bits towards the left, so what will this give me? This will be 0, shift it like this, 0 0 1. Now this is an empty place, this will be filled with 0. This is shifted by 1 bit, shifted by 1 position or 1 bit. Now when I shift it once more, this is nothing but x left shift by 1. Okay, now when I shift it once again, how will this become? I will get 1 0 0 1 0 and one more place will be empty here, I will have 0. Okay, so this is basically shifting x by 2 position, x left shift by 2, x left shift by 2, right? So the answer for this, it will be in decimal, the answer is 36. In octal it is 44. Now you have to observe one thing here, right? Value of the value of a is, when I shift it once, the value of x is 18, yeah, it's 18, and in octal it is 22. When I shift it once again, it becomes 36 and it becomes 44. Okay, so this is the answer for it. You have to observe one thing. Your left shift is nothing but multiplication by 2. Multiplication by 2. One time if you do, it is multiplication by 2. Okay, and if you do it once again, it is again multiply that number by 2. So if the value of x was 9, when I left shifted it once, okay, into 2, I got the answer as 18. When I again shifted it left, okay, into 2, I got the answer as 36. Right? I got the answer as 36. Fine. Similarly, right shift is shifting the bit positions towards the right. Okay, we'll just see how that works. So I have x as 0 0 1 0 0 1. When I perform a right shift by 1, so how will this look like? 0 0 0 1 0 0. Correct? So this will give me an answer of 4. Again, when I perform a right shift on this by 1, I will get the answer as 0 0 0, okay, 1 0. This is nothing but 2. This is nothing but 2. Okay, so that is what we have got. So basically your right shift will perform a division by 2 for one shifting. Another shifting you will get one more. Once more you will be dividing a number by 2. So basically left shift is multiplying a number, and right shift is dividing a number, Okay, we'll just have a look at the example. Okay, this is different example. Fine, but you can just compile, write a program for this, and you can check your answers, right? Okay, coming to a conditional operator, it has 3 expressions as discussed: expression 1, expression 2 and expression 3. And what is that operator? It is question mark followed by an colon, right? So how is this evaluated? Expression 1 is evaluated first, right? It is usually a relational operator or a logical operator. If it results into a non-zero, okay, then expression 2 is evaluated, okay, and its value is the final result, right? If it is false, if this expression will give you false, okay, expression 3 is evaluated and that becomes your final result. For example, I have m is equal to 1 and n is equal to 2. I have one more variable as minimum, so that I keep it as my left hand side. I first check the first expression, m is less than n, that is 1 is less than 2. Okay, condition is true, so m will be the final result. So what is m? M is equal to 1, that will be assigned to your minimum. Okay, now if it was something like this, 2 and 1, m is less than n, the condition is false, so n will be assigned to your minimum. This can again be an expression, it need not be a value. Okay, now check with one more example here. For the same case, m equal to 1 and n equal to 2, is the condition true? Yes, 1 is less than 2. We will evaluate this. However, n value remains unchanged. Okay, m will be assigned to min and it will be incremented. So here I have m is equal to 1, n is equal to 2, correct? Okay, so 1 is less than 2, condition becomes true, so min it will be assigned with 1. In the memory, m becomes 2. Okay, this n, it will not be evaluated and it will not be incremented at all. Fine. Coming to comma operator, it allows to evaluate multiple expressions which are separated by comma from left to right. Okay, so the general form is something like this: expression 1, comma expression 2, comma expression 3, and so on, right? One thing you have to remember, they are strictly evaluated from left to right and their values are discarded except the last one, which becomes the final value of your expression, right? For example, I have m equal to 1 and I have this expression as m is equal to m plus 3. So in this case, this becomes m becomes 3, right? Now 3 mod 3, I have a comma operator here, 3 mod 3, what is the answer? The result is 0. This will be assigned to your n, right? So in this case, again same thing is here, m is equal to 1, yeah, this is the same expression, fine. Now finally the size of operator, it is used in calculating the size of, it is used in calculating the size of any data item. It takes in a single operand, it might be a name of a variable or it can be your data type itself, okay, and returns the size of the operand in bytes. And one thing you have to remember, the return value of size of is totally machine dependent, whether you have a 32-bit machine or a 64-bit machine. Okay, we'll just have a look at one example here. Okay, so I have taken the size of all the data types. We'll just run this program to check the output. So the size of char is 1 bytes, short is 2 bytes, int is 4, long int is 8, float is 4, double is 8, right? Okay, so float, this is a floating point value, it's again 8 bytes, fine. This is long float, 16 bytes, right? And if at all it is a string, right? String is character plus a null character, so the answer will be 6 bytes, right? So this ends the discussion of all the operators that are available in C. Thank you.